Good evening, everyone. It's that time again. While we're all just hanging out, by all I mean just me. I'm gonna share the stream real quick once I get something relatively interesting up here to look at. Yeah, there we go. Cool. We got both screens going on. So come back here and we're just gonna share our stream here real quick. Let's go like a normal feed post. Feeling stressed. No emojis. Post that joint to Facebook. Sharing a post. Gonna do Python, hashtag data science, statistics, linear regression. Post that joint up on LinkedIn. And we're gonna do one more to Instagram. I know that when I post Instagram stories, they go to my Facebook story, but I wonder if it goes the other way around, because that would make it a lot easier. Then I could like just post to Facebook, like my Facebook story also, and then it would just automatically go to Instagram, maybe. How did I post the Instagram story last time? I don't want to make like a normal post though. want to share it to my story. How did I do that last time? Not the plus button, I guess, apparently. Oh well, we'll do it to the Facebook story as well, I guess. Now we shall see if that posts to the Instagram as well. So I just posted the Facebook story. Nope, it does not. Well, huh. How odd. I cannot remember how I definitely posted the link on my story last time, on my Instagram story, but I don't see it here anymore. Huh. All it's letting me do is post like a regular post. How odd. Alright, well, I'm not going to waste any more time on that. It's pretty late. I'm pretty sleepy. I've been working all day and then training for a while. And I want to go to bed. But also just needed to do some work and figured might as well stream while I'm at it. My apartment right now is this really weird temperature where like I can't get, it's like either too hot or too cold. Okay, first thing I want to figure out is how to fold and unfold all in VS Code. Control K and Control 0. Are you sure? Could have sworn it was something like weirder. Let me see here. Yeah, that doesn't work. How to collapse all folders in VS Code. Control plus K plus 0. Haha, that's it. That's the one. That's the one. Now how do I undo it? Not that. Not that. Maybe it's just the same button. It is not the same button. I'll share Stack Overflow with you guys a little bit. But this does not meet the. I know there's a shortcut keys like Control Shift square bracket. Control KJ. Aha. Nifty. Cool. So I did a little bit of work. I finally got into EDA 4. So I'll run through it from the top. Talk about what it did. As you can see, my imports have drastically increased over time. I don't really need these right now. I'm not really using them, but I might use them. So weird SNS display. So yeah, in Seaborn there's this method or visualization called dist plot with a T, and they're, I guess, phasing it out in lieu of this other method called displot with like no T, but it doesn't visualize exactly the same way that I want. So I'm using distplot for now, and it throws a bunch of like warnings and stuff. So that's all that is. Anyway, so we still got this create VIF dictionary. I modified this a little bit so that it actually returns to you a list or two lists of like the features with variance inflation factors below 10 and variance inflation factors 10 or above. So that's nifty. R-squared dictionary hasn't really changed anything. Stepwise selection's been really cool. Oh, it like folds all. Interesting. Nifty. This is, I got tired of writing all this code. So I just put it onto a function, and basically all this does, it runs a recursive feature elimination, and it spits out at you, fuck, now I'm gonna have to, excuse me, now I'm gonna have to figure out how to unfold just a certain region. Yeah, there's no return value here because it just like, why is there no return value here? I think it just prints it automatically. Yeah. What the heck? That's kind of odd. Yeah, that should have this return line right here. Whoops. And this is a little different. And rankers. There we go. And this is just printing a ordinary least squares linear regression model. Because again, I just got tired of typing this little block here all the time. So now all I have to do is type this one little line with whatever predictor data I have, and y is always going to be the same thing. It's always that same target variable. So that was me kind of being lazy, but also not lazy, because like I bothered to make a function out of it, but it was because I didn't want to write a bunch of code, the same code like all the time. Now watch me forget in the future how to write that code. Anyway, Control K0, yeah, nifty. And this, so this is run RFE. This runs a recursive feature elimination, and this is the same thing. Only it runs recursive feature elimination with cross validation, and we won't get into what that means exactly, but you'll see in a minute that I basically found that this function is probably never going to get used because this is a much more reliable result. Yeah. So we were, I killed like 4 hours the other day trying to figure out some error with I was on that stats models OLS method, and it was telling me like my indog, my exog were not the same shape or dimensions or whatever, and I was like, what the heck is like an indog and an exog and all this? All it was that I was declaring y, my target variable, so I'm trying to predict with all this is like the price of the house. Before it was above this line right here, so like this line right here was actually right here. So I declared y, and then I ended up dropping these values here. There wasn't a ton of them, but of all the NaN values in the whole data set, these question marks and square foot basement were the only ones that I could not like justifiably come up with some kind of like substitute value, right? Like with grade, for instance, wherever it is, like, so like there were some strings there was like where none was 0, and so then there's also some NaN values, and I was like, that's none and NaN are basically the same thing, so I'll just make all the NaN 0. These question marks and square foot basement were the only one that I couldn't really justify doing anything like that, because like, does this mean that there isn't a basement? Does it mean the basement just wasn't measured? Like, you know, and it was like less than 5% of the total data, and I've been told that you can comfortably like get rid of or let go of up to like 5% of your data. Beyond that, you start getting into like sampling issues and whatnot. So anyway, that was throwing this like really weird error, and yeah, I'm tired. All it was that y which was a data series as opposed to a data frame, because it's only like the one column, was longer than the X data frame. It had more rows in it. Y had more rows than X. So I spent like 4 hours trying to read through Stack Overflow and W3 schools and all this stuff. Come to find out, all it was, I just had to move Y to like the next line there. So moral of the story is, if you're doing any kind of statistical programming, make sure that your different pieces of data have the same dimensions, and watch out for tricky stuff like that you know, it turned out to not be a really complicated problem. It was just but the error that it threw was really weird. Also, moral of the story is like, learn how to read errors and get familiar with what they mean and stuff. I was really glad that I was able to spot that and like not just spot it, but like figure it out on my own without going to one of my instructors and being like, "Hey, what's this? Like, what's going on here?" Because like, how much of a dumbass would I have felt like to come to find out that it was just that? So anyway, yeah. So I've gone over this a couple times in the videos. This is just all making sure that all of my data is in a numerical type. I'm gonna clear all these outputs and run all the way down to, so we checked the multicollinearity here. We saw that last time. These are the ones that drop based on multicollinearity. And then we establish our inferred features here, our ratios and our differences. Oh man, I'm sorry. Okay. And we're going to run everything above right here. Right out the gate. And wait very patiently as usual. This notebook is becoming very compute intensive. But it's running way faster than that EDA 2 or 3, whichever the first live stream was. We don't have any like 30-second running cells anymore, so that's awesome. I might as well run this too. So this is kind of where I picked up from last time that I didn't stream about. So all this is doing standardization of the data. So the formula here is x minus x bar, which is your mean, over sigma, which is your standard deviation. So you can see I got numpy.mean and numpy.standard deviation here. And what it does is it crams all the values to be something between 0 and 1, right? So imagine like the data keeps the same like proportions and shape and whatnot. Proportions. This is my understanding of it too. I'm not an expert on this. But my understanding is that it makes all the values like be equal to something between 0 and 1, and but it maintains like the nature of the data, if you will, because it maintains like the proportions and whatnot. This is useful to do because you have different values that are in different units of measurement, right? So I have measurements of time here, like the date and the year is built and whatnot. You have price, which is a monetary measurement. You have square footage, which is like a spatial measurement. You have all these different units of measurement and like worlds of measurement. You know what I mean? Like time. There's measurements of time, measurements of space, and measurements of value and whatnot. So it makes it so that everything is kind of using the same unit of measurement, so to speak, right? The standardization makes it so that you can justifiably compare age as a predictor to square footage as a predictor, because now they're kind of using the same units of measurement. Again, disclaimer, I'm not an expert. I am a student. This is a school project, and that's my understanding of it so far. I should probably, while I'm thinking about it, leave a note in the chat in case anybody joins in. Cool. Back to VS Code. And y'all are, in fact, seeing VS Code right now, yeah? Okay. So anyway, this is what XS is it's all the features that remain after removing these based on multicollinearity, and standardizing those features. That's what XS is. All the features that are, for the most part, not collinear with each other, and they've been standardized. XD is before the standardization. So we'll just go ahead and do this. And see, look how nifty this is. That all that little stats models, like junk, man. One line of code. Boom. Functions are awesome. So you can see that this is, we have our squared value of 0.629, which is a lot better than anything we've seen so far, right? Um, this isn't great, but it's, like I said, it's a lot better than everything we've seen so far. This Dark Barra is still kind of crazy to me. I feel like that should not be nearly that. You want skew to be like 1, and you want your kurtosis to be like 3 or less. So these are still pretty crazy. And we're still getting like a multicollinearity warning here from the model. So, and this one, I should probably understand what that means better than I do, but it shows up basically all the time. So, anyway, and you can see Floors here has a astronomical p-value, and relative lot size is like just enough that it's worth dropping. 0.05 is kind of your threshold, generally speaking. So what I ended up doing was I used a few different feature selection methods, and some of them did basically nothing. So by feature selection methods, I mean like further excluding some of these features to get the best set of features. By the time this is all said and done, I'm imagining I'm going to have like 3 or 4 features left. So anyway, a few of them spit out basically the same as that baseline model. So we got R squared 629, same skew, same JB, same Durbin Watson, blah 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 blah. The stepwise selection did remove those features with the excessive p-values, which means our stepwise selection function is working good. So that's cool. We still have like really crazy coefficients over here too. Like what the heck is this? Honestly, that's not as bizarre of a number as like some of these are right here. But anyway, as you can see, it literally changed nothing about the model, except maybe this F statistics is a little weird here, and I don't know what the F statistic is. I've read about it before, but it was never harped on a whole lot in the lessons in Fodar in school, so I don't recall it. Using this is what I was saying earlier, you're gonna see that the RFECV recursive feature elimination with cross validation is a lot stronger than RFE alone, because this one was what? Man, item wrong link 15 instead of what? I think I know what is going on. You'll recall from earlier that this RFE function, run RFE function right here, was not, didn't have that return line, and I accidentally put the wrong variables on the return line because I want this list right here returned, not this. Because, like, yeah, Pandas isn't going to know what to do with, like, bool values when you're indexing columns with it. Obviously. List of columns. So that is correct. Control K0. Ha! Ha! I'm so smart. Where'd that error go? Oh, it's not an error anymore because I commented the thing. Okay. All that just to show you my absolute garbage data frame. Compared to the other ones, this maybe just garbage would have been good. But R squared value of 416 is unacceptable. Clearly. But the recursive elimination with cross-validation, again, is nearly identical to the baseline model. So, yeah. And and so then I did, oh my god. How did I not getting these errors the other day when I ran this? Oh, here it is. Probably because I didn't reset my kernel. And I typoed vifdict. Okay. So this is a great example of why it's important to clear your kernel periodically, because sometimes you'll get code that works because like the variable is still declared in memory somewhere, and it can call it, and then you'll be thinking this function is what's being called, and it's really like that variable that's not written on the screen anywhere, but it's still like there in memory. So, oh my god, what are you talking about? I bet vifdict's on the return line. I didn't do anything to the return line. Or vifdict. It wasn't the return line, but cool. Now, I believe, knock on wood, now it should work. Yeah. Okay, so this is basically manually dropping features that have high p values. You'll notice I'm dropping from XS here, not XD. So like relative lot size had too much of a p value, and then floors too, but floor is also in the bad vifs, so we're dropping those here as well, and we're returning another trash model. Yesterday this was like 0.316. And seeing those errors now, that makes sense that this is not as bad as I thought it was. It's still pretty bad, though. It's not useful. The F statistic is much lower, which I feel like is probably a good thing. So what I'm gonna do is there's like 4 assumptions. Where's my notebook? Oh man, I'm so sore. When you're doing a linear regression model, there's like 4 assumptions. There's 4 assumptions that have to be met about the data itself. Going in there. So the first one is the assumption of linearity. So meaning you're assuming that there has to be some degree of linear relationship between your predictor and your target variable, or in other words, your x axis and your y axis. So that, I've been told, is something that you kind of just check periodically as you go along and tune the model. It's not something that you can necessarily just check off the list and move on with, like, out the gate. Then you have your normality assumption, which is, so there's this thing in statistics called the standard normal distribution. And if you don't know anything about statistics, it's basically like your perfect bell curve. The mean is at 0, and the maximum and the minimum are, I believe, 3 standard deviations. Let me just show you guys. Before I stick my foot in my mouth. Because what would be really terrible is for one of my instructors to find this YouTube channel and listen to me talk about a bunch of stuff that I'm supposed to know and talk about it like I don't know what I'm talking about. The normal standard distribution. Go to bed, Seth. Go to bed soon. I don't know what table is talking about. Here we go. This picture right here. Yeah, so your mean is at 0. Your z-score is just like how many standard deviations you are from the mean. And there's, okay, this is a better visualization right here. Yeah, so 68.2% of your data falls within 1 standard deviation of the mean, 13.6 within 2, and 4.2, sorry, yeah, 99.7 falls within 3 standard deviations, 95.4 falls within 2, and 68.2 falls within 1. Your mean is at 0. Yeah, and your maximum, your minimum are roughly 3 standard deviations away from the mean. Maybe a little further, I guess, according to this visualization right here. The values on the y-axis here don't really matter a whole lot. This could be as tall or as short or whatever, but as long as it follows these proportions, it's considered the standard normal distribution. So this is pretty much representative of a perfect data set. I'm gonna go to the bathroom real quick, and while I let you guys take a look at that. Oh, man. Okay. I wonder if Is this comfy over the thing? Yeah, cool. Yeah, I'm gonna play some Spotify. Cool. You know where I go when you're dancing. Okay, yeah, so I was about to start spitting off these numbers right here, and that's what I wanted to double check myself on. And I say your maximum, your minimum is within three standard deviations. Nearly, right? So as you can see, 99.7% of the sample, or population, depending on the context, falls within three standard deviations, and you have this, 3% or sorry, 0.03% of stuff that falls just outside of it. Yeah. So anyway, there's some statistical tricks and stuff available to. Now I can't hear myself think. There's some statistical tricks and things available to sort of make your data fit that better, like get closer to being normally distributed. So anyway, back to there's these four assumptions, like that the linearity assumption that there's a linear relationship between your predictor and your target. The normality assumption is the assumption that your residuals are normally distributed, not the data itself. Okay? So, this is why you have to build a baseline model first and then start kind of checking for normality, because what your residuals are is the distance. What a residual is the distance between a data point and the predicted data point, right? So if I have some graph, right? Well, I don't know if that filter is gonna actually. Yeah, it's gonna blur it out a little bit, but yeah. So you have like some scatter plot, right? And then you have like a regression line in there. So you might have a bunch of data scattered around. So you'll have a bunch of data scattered around like so. And then you're going to have a regression line in there, which is basically what the OLS model is guessing what the Y value should be, right, is what that line is. And the residual is just the distance between a given data point and, you can't see my dotted line very well there, but it's the distance between a given data point and that regression line, right? So the normality assumption is the assumption that the residuals of the data are normally distributed. Don't ask me why. So there's a few different ways to check that. Your third assumption is the assumption of homoscedasticity, which is basically like the easiest way to deal with that is just checking your Durbin-Watson score, which you want to be like pretty close to 2, and all of our models are like 1.99 something, so that's fine. But homoscedasticity is basically the idea that like, or if something is homoscedastic, homoscedastic. I don't know which one's correct, but if there's like kind of like a clear grouping like in a like certain direction. So, you know, let me. Oh wow, I'm like showing you guys my stream thing right now. Sorry. I gotta figure out like a efficient way to switch back and forth between like the web browser sharing and like the VS Code sharing. Anyway, homoscedasticity. So this is a homoscedastic chunk of data where it has like this line here, right? And okay, here's a really great visual. And this is heteroscedastic, which so you can see how if something if the linearity assumption is satisfied, then there's a good chance that the homoscedasticity assumption is also satisfied. But yeah, that's basically what it means, is that you can like visually see like a kind of trend or line or whatever. It doesn't necessarily have to be. Sorry. Going from the bottom left to the top right, it could go the other way as long as it has that like grouping. And then your fourth assumption is the assumption of multicollinearity, which that's multicollinearity is this like idea, or collinearity alone is how strongly like two different features correlate with each other, right? So like relative lot size and lot size are represent basically the same, or they're sorry, that's not correct. Relative lot size and lot size might correlate with each other like very strongly. They do, in fact, and that means that they're going to tell the model basically the same thing. They're going to predict the same thing for the model. So if you have both of those present in the model, it's going to kind of like exaggerate the prediction and like the confidence of the prediction and whatnot, so to speak. So you don't want anything, you don't want a whole lot of multicollinearity in your model. There's always going to be some collinearity, probably, but that's what this was all about, right? I think I did this on the last stream, or at least some of it. So what this is the correlation coefficients, as noted by CC, of these specific pairs of features. And what this data frame is all the pairs of features that have correlation coefficients within 60% and 100%, or 0.6 and 1. So if something has a correlation coefficient of like 20%, then like, so what type of deal. I think the sort of rule of thumb or standard is like 70 or 75. I just had a ton of features, and like I said, I'm anticipating this getting narrowed down to like 3 or 4. So at this point, with like 18 features or whatever it is that I have, like I can stand to like lose a few. So I just increased that threshold to 0.6. And as you can see, like we don't get anything at like 0.61, 0.62, so it wasn't really interesting to go past that. So anyways, these are the most correlated or collinear pairs of features in the data. So the wisdom basically is that at least one of these from each of these pairs has to go. Some of these show up in multiple pairs, and so I basically sat here and I manually just like tallied every single one that I saw, and I ended up deciding to drop square foot living and keep square foot or relative living space, because if you look closely, relative living space only shows up one time here, but square foot living shows up 4 different times. So square foot living is collinear with a lot of different things, which makes sense because that's probably like a pretty vanilla predictor, if you will, of like the price of a house, the square footage of it. And remember, relative living space is like how the square footage of a house compares to the square footage of the other ones around it. So like the neighborhood that a house is in matters as well, right? And so like when I created the relative living space feature, my idea was like, well, let me like kind of what's the correct word? Aggregate those two sort of chunks of information into one feature, right? Like the square footage of the actual house and how that house kind of ranks in its neighborhood, right? And that's also kind of an indication of like the neighborhood itself, maybe. I started to say it and then I started to say it out loud and I was like, oh, that might not be correct. But anyway, point being, square foot living was collinear with a lot of different things. Relative living space was only collinear with square foot of living within this data frame. I'm sure it's has some collinearity with other features, but it's the only one that it's highly correlated with. So as weird as that is to me, like the thought of like dropping square foot living, like when I first started this project, if I would have just looked at all the columns, I would have bet good money that square foot of living would have made it through the filter, so to speak. But that was before I would have thought of making the relative living space feature. So anyway, I hope that doesn't come back to bite me, but I feel like I can at least make a strong argument for it because of this. Like the argument that square foot living is collinear with many different features and relative living space is only collinear with square foot living, but it's not collinear with the things that square foot living is collinear with. So that was my logic there. Anyway, so that's like your 4 assumptions. Your normality assumption, your linearity assumption, homoscedasticity assumption, and multicollinearity assumption. So, like I said, a lot of these models are not awesome, or as awesome as I want them to be. So, I think I'm going to insert in here some stuff before I start getting to the feature. So I'm going to do some feature tuning before I get into the feature selection method. So in these cells here, I'm going to do a little bit more feature tuning, like maybe some log transformation, because that generally makes things more, I don't want to say more normal, more likely to satisfy the normality assumption. I'm going to tune the data here in a little bit more, and I'm really stepping into the mathy area that I'm a little less confident with. I can write Python till the cows come home, but the statistics stuff is difficult. My degree is in a foreign language, and so I've done some statistics, and I did well in it when I did it, but it's been a few years. So yeah, that's kind of where I'm at right now. I have none of my feature selection creates a model that's any stronger than my baseline model. So that means that I need to tune the data a little bit. So I have a few different tools available to me. A QQ plot can kind of show you how well a feature satisfies the normality assumption, which is probably where I'll start. I have some note here that says histogram of model.resID 2, and I don't exactly remember what that means. Not entirely, so I might check that out as well. because I don't know if this. Maybe my print model function needs to return like the model itself. And I'll change this to run model. Run OLS model. I'll have to change like some of the cells down below, but I don't see a problem with that at the moment, because then I can just do model equals run OLS model. We'll deal with that later. We're not even going to touch that right now, but we will do it here. Because I need to have model available to call methods on it. And the print model only prints out the report, the stats models report thing. So I can do this. It's not going to do anything, but now I can do model dot summary. And what does this method do? I mean, that's obviously like a series of residuals. Also, why do we have 21,000? This should be like 143 features. I have like a print nulls function, right? Or like a null dict function. No, I don't. Where'd it go? I'm just checking some stuff while this loads for me. Let's collapse all that. Dude, I wrote this sick function the other day that gave me a dictionary or something of like if stuff's null or not. What happened to it? Bro, I don't understand why sometimes I single click and it opens like in a new tab, and sometimes it just single click and it just changes like what the tab is, and then sometimes I double click it and like dude, I'd like legit need to just take a Udemy course on VS Code. What is going on here? Oh my gosh, I'm fading fast. It's after midnight. I need to sleep. Dude, what the heck? Okay, that's not really helpful. What I want to know. Oh, these are index positions. Yeah, the length of it is still the... Okay. Wow, that was a whole lot of stressing for nothing. Okay, so this is obviously showing me like a list or a series of residuals, but like for what feature or... I don't know. Stack Overflow, here I come. Gross, I hate Stack Overflow so much. Stats models. I'm Googling right now. Model dot resid. The residuals of the model. Okay. That's hilarious. This is the whole docs, like the official stats models docs on this method. Thanks. That helps. Not a lot at all. I mean, I guess, okay, so it's just like the residuals of like all the predictors versus the target. Okay. So a histogram of model.resID. Let's see what that looks like. Can I call like .hist on that? Let me like not. Let me do this in a different cell so I'm not running like a freaking new model like every 5 seconds. I don't think it's gonna work. Oh wow. Okay, so this is definitely not normally distributed. Like even a little bit. So that's good to know. So point being, the closer we can get this shape to represent that standard normal distribution I was showing you earlier, the better. The thing is, like, how do I want to do that? Because I have a lot of different tools available to approach such things. And it's going to be a little bit of guesswork, or trial and error, rather. I'm also deciding like how deep into this I want to get into tonight. Exactly. That's good information to see, though. So I think what I want to do now is I want to look at a QQ plot of each feature. Because some of them might be normally distributed and some of them might not be. Some of their residuals might be normally distributed, some others might not be. So I have to remember how to a QQ plot. I'm pretty sure it's Pandas. No, sorry. Matplotlib. I mean, maybe it's Pandas. I don't know. Let me go look at the course material real quick. I'd like to screen share some of this stuff, but I don't know if that's allowed because I'm paying a lot of money to go to this program. They're charging me a lot of money to be able to have this course material, so I want to ask like my cohort leader or somebody soon about that, because they also really like you to blog and stuff, but I don't want to just be handing out their like course material. Model fit regression. Oh, clicked the wrong button. I don't think that's not gonna tell me a whole lot. No, it's not. That's my body telling me it's time to go to bed, but I'm too stubborn. Feature scaling and normalization might be helpful to look at. I'm trying to find a lesson right now that specifically showed how to create a QQ plot. And also, like, I need to keep in mind, I keep forgetting that for the sake of the project, I have to basically one hot encode at least one variable, one categorical variable. I have to demonstrate those skills. So that alone might improve the model a little bit if I just figure out which is the best feature for that and then one hot encode it. But all my categorical variables are ordinal rather than nominal. So nominal is like, imagine like different car models, like a Bronco versus Mustang versus a Camry or whatever. It's not like necessarily a ranking, it's just different stuff. Versus ordinal is like my grade feature is what would you say? It's gosh, I'm so tired. Grade is ordinal because like 5 is better than 4 is better than 3 is better than 2 and so on. So there's that to keep in mind. I don't have any categorical variables that are like clearly oh my gosh. I don't have any categorical variables that are clearly nominal. So I either have to create one or like infer one, or just pick one and just one hot encode it anyway. So anyway, back to what I was originally looking at. Might have been regression model validation? I don't think so. Okay, I'm just gonna straight up Google Python QQ plot. Geeks for Geeks. This is a good website. Geeks for Geeks usually comes in clutch. They just always like 30 seconds after you like scrolling through the web page. I'm gonna show you this. Stop doing this. Please, for the love of God, stop doing this. This is so frustrating. I've already caved and made an account on your web server. Now you want to get all like, stop. Thanks for coming to my TED Talk. Anyway, I'm always just going to click skip because it's easier than filling all this junk out that I don't want you to have. If you really wanted to figure out what school I go to or what my phone number is, like, it's out there on the internet. It's not that hard to find. Okay, I know what a QQ plot is. I just want the code. I don't know why this is using PyLab. I don't know what PyLab is, but they're just using it for that, which you can just use plot matplotlib dot show for that. So sm.qqplot. Okay, so it's stats models that has the QQ plot, not matplotlib. That makes sense. Anyway, so I could go through and manually do that for every feature, or I could, if I really hate myself, I can try to make a scatter deal of this. But first, let me do like just some old feature. We're passing excess in the model, so we need to use excess. Relative living space. My heart's gonna be so broken. Wow. So, as you might have gathered from that's why they did the PyLab thing. So these blue dots should be in line with this red line, basically. So that's not awesome. So I can do a log transformation, and that might help. P.log access to living space. Logged. That's only variable I have to pass in, right? Yeah. Do not need this parentheses though. Okay, so that got better, sort of. So I'm just gonna write a for loop to do that. Columns log equals np.log. Whoops. Feature. And so this should do that basically for every feature we have in the set. Oh my goodness. Oh my god, okay. You know what? Just out of curiosity, let's see what this looks like before we do standardization on the features. It's the same as you would expect, because like I said, the standardization doesn't actually affect like the information itself. This is interesting. I should add some labels so I know what the heck feature that is. What dot title? Yeah, title. Is feature so bedrooms floors should be dropped. So bed bath ratio is like not bad. Live lot ratios maybe even better than bed bath ratio. How do I recently I somehow put all that into like a matrix plot thing so you can see it all at once. Oh, this is gonna take forever. Yeah, even the dog's asleep. I don't know why, but this whole notebook runs like molasses. Like, why does EDA2 like take 30 seconds to just to import 21, excuse me. And it doesn't EDA4. I'm gonna fall asleep waiting for the cell to run. There it is. Okay. right off the top of my head, this isn't even the data that I'm working with right now, but just dropping some outliers might help quite a bit. So anyway, this kind of template, if you will, is what I was looking for, because that should work. For the QQ plot as well. So for index feature in enumerate. Dude, I'm forgetting like words and how to spell and stuff. Like I can't imagine. I can't remember how to spell, and how am I gonna do brain stuff? Brain stuff. For features. Looking brand new. I try to tell you what to do. I'm just trying to play it cool. Baby, I ain't playing by your rules. It's better whatever you. Why you always in a mood? Looking around, looking brand new. I ain't trying to tell you what to do. I'm just trying to play it cool. Baby, I ain't playing by your rules. So this should produce this, but in QQ plots. And I say should because you never know. Okay. I'm just gonna have to let that finish running. Okay, so I need to check how many features I'm dealing with first to know exactly what dimension to make this matrix. We're looking at XD right now, aren't we? Why did I just type a line? 15, okay. So I should be able to do 5 and 3. What the heck? I bet. Why doesn't declare? It's probably gonna throw an error. If I had to guess. Maybe not. Yeah, okay. Ugh. I don't think this is gonna work. I'm gonna be amazed if this doesn't throw an error. What the heck? Bro, I just want like a matrix of QQ plots. So I don't have to scroll for 5 miles every time I run it. That's all I want. That's all I want in life. Create matrix of Q. That's not a Q. QQ plots in Python. I'm deflating really quickly, and I can definitely tell I'm not like thinking at my best, and it might be better to pick this back up when I don't have mashed potatoes for brains. At least I can still laugh at myself. Yeah. The fact that this QQ plot is coming from stats models and not from your typical data viz libraries like Matplotlib or Seaborn. And I don't know how much of so this is the stats models library with the graphics module in stats models library. I don't know how much how much of the graphics module was like built on top of or with Matplotlib, because I know like Seaborn was like first came along Matplotlib, and then other people came along and made Seaborn using a lot of Matplotlib stuff. I don't know if that's the case with the graphics module from stats models, and so I don't know that the techniques that I would normally use to make Seaborn do Matplotlib type stuff, I don't know if that's going to work necessarily. Or it's clearly not working at present. So all we really have going for ourselves right now is what I want to do is have like a matrix of like the features before they're standardized and the feature in a matrix of the QQ plots of the features after they're standardized and see how those look against each other. That's what I'm trying to get to. But it's not working out for me right now. Man, I really wanted to, by the end of the stream, have some model that's like a little better than the baseline model at least. But I'm kind of losing hope that that's going to happen tonight. The heck? So what else can I do? I can log transform the data and then run an OLS model and then look at the model residual histogram. So that would be why is xlog not xs dot columns little x logged equals numpy dot log xs feature, and then I need to do xlog feature equals x logged. Okay. Oh, of course. So when I log transform, I'm sure there's a lot of things that turn out to be zero. Like for relative living space, for example, a lot of times like the value is zero, but in that particular instance, that zero is a meaningful zero. In the instance of the relative lot size feature, zero means that the house is the same size as the 15 others around it, not bigger or smaller. So it's a meaningful zero. And I think when you do this log transformation, it's going to automatically make those zeros nans, and it sometimes produces these like negative infinity values, which is annoying as all get out. Condition has zero non-null. Wow. Oh my god. So I say oh my god because the original data is 21,143 records long. And all these numbers are how many of that 21 some odd thousand are non-nulls. So as you can see, most of these, with the exception of year built and date, there's like a ton of nan values. Um, how do I find? I'm assuming there's like some nymph values in here somewhere. What I don't know is how to like look for that for all the columns. Like I want just literally any row that has a nymph value. np dot nymph, meaning negative infinity. I don't want to select based on column values. I want to select based on row values. This is part why I really like streaming is I think out loud, and that makes me catch some things that I normally wouldn't. I don't think there's like a quick and dirty handoffs method that will do that. Unfortunately. But like let's look at relative living space real quick. So maybe I don't have any negative infinities. So I basically want to iterate through every column and then iterate through every row and replace any nans with zeros. And I can do column dot replace why is this not? It's weird. And I'm gonna double check my syntax here real quick. My parameters, rather. I think that's right. I need this. I think that'll do it. Takes no keyword arguments. What are you talking about? To replace. Is that how you spell replace? Yes. What does that mean? Okay, so in relative living space, index 1 is, index 2 is a nan value. Dude, I'm about to just start learning how to fucking code in Vim because I'm so like why wouldn't it do that the first time? It was like jumping like anyway. I'm getting way too tired and grumpy. Oh my god. Want to jump off a bridge? Not really. NumPy.float.64. Yeah, so calling like an np.nan should be like this is what I'm talking about. I don't want to go to the end of the I don't understand what it means by keyword arguments. This has nothing to do with that. Is that a thing? What if I just do like positional arguments? Okay. And for loop, yeah, that's exactly what I'm dealing with. Wow. Wow, I am dumb. Oh my god. Get it together, man. I ain't trying to tell you what to do. I'm just trying to play it cool. Everybody rules. Okay. What did I do this for? Oh yeah, to look at the okay. So log residuals equal that, and I want to do dot hist log residuals gross. Okay, it's time to go to bed. I wanted to get some model with a better R-square value by the end of the stream. That's not happening. And I honestly don't really know what to do next to make that happen, even if I had the time or the energy to stay and keep working on this. Fortunately, I'm meeting with my cohort leader tomorrow. I just got a new cohort leader because my existing one was transferred to a different department. He's with the enterprise team now, so he's going to be helping with job placement and stuff. So hopefully I'll bump into him again when I start looking for a job. But that's only going to happen if I can finish this project, which is I'm like weeks behind on. Anyway, point being, I'm meeting with him tomorrow, so hopefully my cohort leader will be able to guide me in the right direction, because at this point kind of exhausted everything I know to do as far as tuning the data to fit the model. So yeah, and short of that, I just have to go and like review the coursework and stuff, and see if I missed something or if there's some. Am I getting audio right now? Yeah, I am. And just see if there's something I missed or something that catches my eye, or I'll just have to kind of like review the coursework, review my labs that I've done, and see what I can come up with. Well, anyway, that's it for this stream. Hopefully next time we'll be a little bit more productive. We'll get something more done.